Welcome, and we're so thrilled to have you here presenting today. And all of these students and schools and teachers have enjoyed seeing your face and your story in our curriculum. So without further ado, I'm just going to hand it off to you.
Thanks, Constance. I'm going to see if I'm good at technology, but from the looks of it, there's a lot of people on this call that are probably better at these things than I am. So can we see this okay? Anyone speak up if not?
Perfect.
All right, awesome. Well, guys, first of all, thank you so much for the invitation to join you here today. It looks like it's been a fun-filled day full of bridge building, team building, kind of exercising those muscles of using your brain and your excitement and enthusiasm and creativity. So I wish I was there in person with all of you, but for those of you that did have a chance to see your bridges, they look incredible. I'm here recruiting, so let's be clear. Lots of bridge builders in that environment translates really well to my passion in the world, which is also building bridges. So I wanted to share a little bit more today about who I am, what gets me excited, and a little bit about why bridges are actually a critical tool for solving poverty around the world. So I like to always start by level setting. Who am I? So, today I'm standing in an office in Colorado, but the majority of my time in the last 15 years has been spent in a construction site all around the world. This particular place is in rural Nicaragua, where as you can kind of see from the attire that I do my best to say always safe, but not always clean. And I think, part of what I've loved about this career, and you don't have to build bridges in developing countries to get this, but you can have a career that is not only designing something and imagining it, but actually building it. And just like you guys are all doing today, it's kind of coming up with the trust structure and the design and thinking about how could we best, capture the load, and then getting to put your tools to work to build it. There's an entire industry of people who do that every single day, and I'm part of that industry in the civil engineering and construction world. So here in Nicaragua, you can tell my office looks very different than sitting in a whiteboard in kind of a white sterile environment. Although honestly, I do both. And I want to tell you a little bit more about why this is my office and why I've had such a deep privilege of having a career in the STEM fields. I like to say it all started with Legos. And just to date myself a little bit, this ad came out in the mid 1980s or early 1980s. And I remember looking at this in the magazines. We didn't have such an attention span to internet, obviously, not being a thing at that point. But you'd flip through magazines and just really be drawn to things. And I remember being like, this is who I am. I wish I was in this Lego ad. And I think if I had had red hair and might have been a little cuter, I would have been a little more competitive. But for me, I think that the built environment and building things and helping people was really in my blood. And Legos was a big part of getting started. If we were all in person, I would probably take a show of hands. How many of you guys had some derivation of Legos or Duplos early on? And I find out that actually, this day and age, you guys might have Legos and it moves into Erectasets and robotics and much more complex moving parts. But for the simpletons back in the 80s, this was really where I got my start and my passion for the STEM fields. And just to simplify and talk about Legos, I also love art. And as I was a kiddo, I was like in elementary school, all the way through high school, I was always involved in art clubs and did a lot of drawing and was pretty actively involved in how to use my creative side of my brain. And I actually think that a lot of engineering and STEM fields are very creative as well. But as I was starting to look at college and started to say, well, hey, what am I going to do in this next phase of my life? I really was like, well, I like the analytical, I like the math, I like the science, I like the building, kind of analogous to the Lego part of my brain. But I also have this part that feels really creative and kind of likes to imagine a world that doesn't exist yet. And whether that's through watercolor or building, let's call it popsicle stick bridges, I always was kind of tinkering and loved to build and create. And so as I was really narrowing down my decision as to where to go and what to do in my next stage, a third component came in. And I was a active athlete at all of your ages. And I was a track runner and a soccer player and an aspiring basketball all-star, but ended up taking a soccer scholarship for a Division I program at the University of Iowa. And so I was kind of coming into college with a lot of uncertainty. And I think if anyone tells you you have to know exactly what you want to do when you grow up, tell them that you probably never will know. I certainly didn't. But combining all of these passions of my sports and my, built environment and art, I thought it would be a great way to, go into the future with an engineering degree and a double major in art. And I remember when I sat down with my counselor, which many of you will be doing, I'm sure, in the next few years, and I explained my vision. I was like, I want to do these math classes and physics, and I really love, lots of different things that are in the kind of engineering school, but I also want to take, metalworking and jewelry, and I also want to take ceramics, and I also want to take life drawing. And they looked at me and they were like, the Venn diagram of overlap between these two degrees is almost nothing. And we're going to take a lot of years to get this done. And so it was like pretty active negotiation of like, what is the priority of what are the things I'm passionate about? And what do I think could give me a meaningful, interesting career? And it ended up being that it did take me 5 years, but I had the opportunity to take classes in chemistry and then go down the hall and take another class in how you can actually see chemistry at work when you're doing metallurgy in a metalworking class for an art degree. And if I could impose one sort of nod of advice to all of you as you guys think about your next chapters, is definitely be unabashedly yourself and be willing to kind of create your own adventure, because I think there's a lot of opportunity as we go into STEM fields in general to help people and to do great things and to have a great career. And there's a great way to have fun and enjoy your path as you get there. But about 3 years into college, I got a little antsy and I started being like, well, is this it? Am I going to just, be an engineer, or am I going to be an artist? Or haven't got any calls from the national team yet, so I don't think I'm going to quite hack it in soccer after college. So I bought a one-way plane ticket to Fiji, which my little arrow here has conveniently overridden where Fiji is exactly, but Fiji is in the South Pacific and is a tiny island that is really well known for beach vacations and celebrities going there and buying out entire islands. But the reality of why I went to Fiji was I wanted to experience a culture and a place so different than my own, and I wanted to have a chance to really reevaluate what was it that I got excited about when I woke up in the morning. I wanted to make a decision as I ended out my college career of, do I want to live in Iowa for the rest of my life? Do I want to be an engineer? Do I want to be an artist? And to get an opportunity to be able to study abroad was probably the single most transformative decision I made before I was 25. And that was big on a lot of levels. I'll tell some of which they're here today. But spoiler alert, I found the thing that really makes me tick. I found my passion. And for all of the ways that you can do this at the soup kitchen down the road. You can do this by having coffees with grandma. You can do this by reading books. I happen to travel halfway around the world, but I found something that got me excited to wake up every morning. And I found something that made sense to me as something that I wanted to put my lifeblood and my life passion into doing. And that thing was found not on the beaches, although the beaches were pretty great, I'm not going to lie. But when I was walking through all of the communities, and I was actually volunteering for an organization analogous to the Breast Cancer Foundation. And every morning we would get up and we'd get in these little kind of like tuk-tuk vans, and we would leave from the capital city where I was going to school. And we'd go out to the nearest community that we could get to, drop the van, and you'd walk in. And the walks could be anywhere from 10 minutes to 3 hours. And what became really evident for me, and where this picture was taken, was oftentimes you couldn't actually get to where you needed to go. So imagine, we've just spent the last 3-4 hours trying to get to this community because the important activity we were doing is to show up and talk to women about the importance of early breast cancer detection. And we were like, hey, there's only one mammogram machine on all of these islands. And so you have to be essentially educating and pursuing a knowledge of your own health condition. But you'd spend 4 hours to get to this community. You'd get to a river and you'd turn around and go home. Or you'd get to a river and you'd be like, well, I'm feeling a little audacious today. I think I could wade through water knee deep. But you're the whole time thinking, what happens if the water rises while I'm over there doing my work? Do I stay here? Do I have enough equipment to live off of? And do I want to eat off of everyone else's food? And then the other question is like, is this even safe? And so one day, after many of these turnaround trips, we came across this bridge. And this is me at 20 years old. And to date myself, I'm 38. So this is almost half my life ago. But we're this very simple structure. And obviously this is a cable supported structure, which we'll talk about in a minute, which is slightly different than the trusses that you guys are working with today. But the difference between this particular community on the other side of the bridge and a few of the other communities that didn't have bridges was we easily were able to go in there and do our work. It was no issue for the crew to walk in, see the kids running back from school, to see the farmer moving with their excess crop on their head, to see the agricultural production moving back and forth. Things were not blocked by the river. And that was just such an aha moment. It was like that moment of passion of like, this is not that hard. And this is transforming the lives of people in the most profound and impactful way. And something that, granted, like I come from a middle class, middle American community, but something that we didn't think about. I did not think about, can I not get to school today until I went to Fiji? I had never thought about, well, what if I get hurt and I can't physically get to the clinic or hospital until I went to Fiji? And it certainly never occurred to me like, well, how do I even make money consistently if I'm not able to predictably get to where I need to go? And when I saw this bridge at 20 years old, it clicked. And it was like, this is something that I can do and I can make a difference. And because I was doing engineering school at the time, and also because I fancy myself fairly creative with this art degree, I was like, we can design and build a bridge. And that will be such an amazing way for me to go back, repatriate to America, go back, finish my college degree, and I'll do a project. And there's a few other things that we'll talk about, but grit and determination was something I learned deeply in this very first next chapter of my life, was coming back from Fiji, going back to college classes. And I was like, okay, guys, let's go build a bridge somewhere in the world that needs it. And to get the blank stares from the professors and from the family members and from my friends, be like, you want to do what? Wait, why? Where do you want to do this? And, that's the kind of thing, guys, that like, if you have a little bit of grit and determination, as long as you've got the passion for it, you can make mountains move. And so, I'm going to skip a lot of detailed steps here, but I think it was really interesting was the difference between me showing up back in Iowa and me being down here in Yavina, Peru, surrounded by the school children who are going to cross this new bridge we're working on every day, as well as a few of my new best friends, was an 18-month journey. It was a convincing the faculty at the University of Iowa that we were capable of having a safe trip that was going to be able to provide value to the folks that we were serving, but also that it was going to make sure that we as 5 University of Iowa students were going to represent the school well and do that safely. It was convincing Bridges to Prosperity, the organization that I subsequently became the CEO of, that we could raise the money and we could also be self-sufficient enough to get ourselves down there. It was convincing the local engineers in the community of Iowa City that we were willing and able to learn how to design these footbridges, even though none of us had degrees yet. And so we had to convince people in the community to put themselves around us and make this possible. But that first trip, we went down to Yavina, Peru, and you can imagine you're flying in, you fly into Lima, you take a second little hopper plane to Cusco. It's actually the launch point of where, if you ever hike Machu Picchu, it's really close, by the way, the bird flies to that area. And then you get off that plane and, we took a night to stay, and then you take a 5-hour, kind of another van bus ride. You drop off, this is where the nearest road is, and then you walked 3 hours through the highest mountains that I've ever been in my life. It's the Peruvian Andes, to finally get to this community. And when we get to this river, this is the low water season. So as you guys are all designing and building your bridges today, we're kind of talking about clearing how wide is the bridge opening. So like, are we having to do it a foot of a gap, or are you doing 10 feet of a gap? Is a big difference, obviously. But something that you didn't have to think about today that you would need to, if you become a bridge engineer, is also how high does the water get? So you could have a gap of 10 feet, you could have a truss, and that water could actually crest over that truss, and that truss could go away. And that's a major design constraint that I had never thought of. So in this case, in Yavina, Peru, here are these braided vines that essentially every single year during the low water season, the community would come together and braid them. And they would make this big pile of rocks. And then on the other side is a much higher kind of abutment, and they'd secure it. But as the water rises, about, I'd say 4 or 5 months of the year, these vines get ripped out. The rocks largely stay, but not the small ones. And the entire access point goes away entirely. And so for those 4 or 5 months of the year, my little buddy Rolio, here crossing this precarious swinging bridge, and all of his friends, his classmates here in Navina, didn't even have an option. It wasn't even like, how scary is this crossing for me to go to school today? It was a, okay, bridge is gone. I'll go to school again next year. And if you can imagine the difference of a life for a young person, if they could just live on that side of the river. It's kind of like we talk about the wrong side of the tracks in a weird and kind of terrible way. But it's like, what if you literally could not get to where you need to go? You're being born on the wrong side of the river. You are being born on the wrong side of not being able to go to school, or not being able to have healthcare, not making sure that your mom actually has an attended birth when you're born. And that difference to me was so motivating that not only did I have a passion for figuring out how to build this bridge, but I found my purpose. And this is something that I think that many people spend lifetime or more trying to find and may never ever land on it. And if I were to have any, suggestions for young people today, is as you kind of find out what in the world gets you excited and you're passionate, if you can pair that with a sense of purpose, something bigger than yourself, something that is giving to someone something or some future that is beyond you, it makes the world go around in a really incredible way. And I do know your generation is going to be one that does this much more readily than mine. And I'm beyond excited by that, because I think if you can find a lot of people who are passionate about something that they want to change in the world, whether that's climate change or whether that's a built environment, or whether that's just, global peace, working incrementally on something you care about and something that is bigger than yourself is going to move mountains in ways that we don't even realize is possible. And this, for me, this sense of purpose launched me. It was a game changer. It went from, I know how to kind of, do the numerical calculations of a bridge, and I was excited about that conceptually, to like, I am designing a bridge where the life and safety of children going to school every day is in my hands, literally and figuratively. And that pushed me into what has now been almost a 18-year passion around bridges. And I like to always make sure people can kind of imagine the places that I'm talking about. So this is a place in I think this is actually in Ethiopia, in Liberia, Pakistan, in Colombia, Indonesia, and back in Ethiopia. This is an issue of access that is the world over. In this particular case, if you can just imagine the desperation to be able to predictably go where you need to get will drive people to do the most, I would say, audacious and brave things. So this particular site is really near and dear to me, and I'll tell you a little story here. But if you can kind of zoom out and imagine that here we are with these multi-arch spans, and you can imagine back in the 1400s when the Portuguese originally put this bridge over the Blue Nile, that arch structure was a perfect way to have a straight line across. You can imagine walking across it as easily as you could have taken a cow or sheep or any number of other kind of push vehicles at that time. But in 1938, the Italian invasion through Ethiopia, through the regions of Gondar going into Gojam, was coming in, and Ethiopia at that time, and to this day, continued to be uncolonized. There had been no external country coming in and invading successfully. And what the people of Ethiopia in this region of Gojam did was they saw the Italians coming, and they said the difference between the Italians coming and invading the rest of the country and being halted here is this bridge. So where bridges also connect for good things, they can also connect for bad. And in this case, they decided to self-destruct one of these arches. So in 1938, you guys can imagine the cementitious material that connects these rocks together was actually made out of an egg. It's a binding agent before cement was a thing. So they're sitting there chiseling out this egg binder and having the rock fall into the river. And this has been what's left for nearly, 80, 90 years. The only way for them to get the 10,000 people who live over in Gondar, the only way for them to get back to Bojang, where all of the communities are, all the schools, anything past the 4th grade, the healthcare clinics, the capital city, the roads to the capital city, everything is on this side. So what they had to do is to get 6 of your best friends on either side of the river, hold the rope, and do what this gentleman is doing, is be quite brave and be pulled across. And I remember the first time that I came to this community in Ethiopia, similar story, right? Many flights, many bus rides, many car rides, and then a lot of walking. So by the time you get here, you're exhausted and you're small. This is the middle of absolute nowhere. But the reality is this is the center of their universe. This is their reality. And the reality is they cannot safely get to the most basic of services to have the most standard quality of life. And so for the folks that are sitting here holding this rope, they're making it possible for their friend to go get a job. They're making it possible for their mother to be strapped to this rope to then go get healthcare. They're making access possible, but certainly not easily and certainly not what I consider safely. So I had the privilege of, I ended up doing a master's degree in engineering. And as part of my thesis, I actually said, well, what if we standardize pedestrian bridge design, specifically cable pedestrian bridge design for rural communities. And this is a bridge that I actually finished building on the day of graduation of my graduate degree. And I think because you guys are all aspiring bridge engineers, I'm going to do another non sequitur, but I think the interesting thing is that the most obvious structure to put on this broken multi-arch span, as you can see in the lower left part of the corner, is like, well, Avery, why don't you just put one of these trusses on there, just like we built today? Just, patch it a little bit and whop it on. Well, going back to what we talked about earlier, is how wide is the opening is one constraint, but how high the river goes is in some ways, much more important one. And what has happened in this region of Ethiopia is that over the years, there's been so much deforestation. And what deforestation has happened is then you end up having erosion. So as the trees get pulled out and all the soil ends up being more accessible to the rain and the conditions, you end up having that soil erode and go into the riverways. And the impact of that is that you end up having the what used to be the bottom of the riverbed is now many, many tens of feet lower. And now we have a sediment buildup. That sediment buildup means that as the water in the flooding season comes, it's that much higher. And so what happened here is the water every season actually comes up and over this original bridge every single year. And so we couldn't, in good conscience, spend time and money just focusing on putting a truss bridge there when we knew we needed to build a bridge much higher up in the valley and put it up into what's called a cable suspended bridge. And I figured by this point, you guys might be a little tired of hearing me tell you about bridges. And I thought I might share a little video that gives you a better sense of kind of the scale and the magnitude of these going together. I'd like you to pay attention to two things. One is think about how you would get cables across the river if they weigh more than a car, and see how we did it in this film. And two, I want you to pay attention to there's two main types of cable supported bridge structures that we focus on. One is here, almost looks like a hammock. It's a suspended bridge. Think about where the loads and kind of as you put a load on somewhere in this bridge, how that structure might behave. And the second kind of bridge we talk about is a suspension bridge, kind of like the Golden Gate. And that's going to be in this video. And I just want you kind of noodling on what might be some of the differences on how the loads might move through the structure. Oop. Don't want to play that again, do it, So that brings me to my kind of third key point is beyond finding passion and purpose. For me personally, centering everything I do on people has been really transformative in how I've thought about my career and how I spend my time. And, for each of us, I think some people love people and just can't wait to be extroverted and out in the world. And some people, thankfully, are much more thoughtful in their experience. And, people can kind of come and go, or just they're very special people are the people they want to spend time with. So I'm not talking about how you relate in your friend groups or in your classrooms or in even the way how extroverted you are, but I'm talking about centering all of our communication and all of our intention around the person across the table from us and the person around the world equally, someone who's maybe going to benefit from our interactions. And for me, people is what wakes me up every morning, and thinking about that one individual who used to not be able to go to school, or that one person who used to not be able to have certainty that she could have an attended birth. And the difference that a bridge in the built environment, and frankly, an engineering and STEM background can make, and the impact on the individual person at the other end of that. So I like to kind of, get people back into what is Bridges to Prosperity and why is this such a big deal? And, I just like to ask each of you individually, just imagine for a minute, if you close your eyes, what would life be like if you had to risk your life just to seek the most basic opportunities? To come here today to do this workshop, what if you had to risk your life just to show up? And start to think about what you might do differently, for better and for worse. Every day, more than 1 billion people around the world, that's about 1 in 7 people, have that as their reality. So there's 1 in 7 people literally can't go to school. And 1 in 7 people can't get their job predictably unless they live entirely on one side of a river. And footbridges are a proven solution, something that I'm passionate about, obviously, and something that you guys all are capable of doing. It's not super complicated. And as you get more excited about, some of you hopefully get into engineering fields and STEM fields more generally, you start to think about how something so simple as a bridge can make it so children can attend school, jobs are secured, farmers are more profitable, and healthcare is accessible to everyone. And I personally am on a life passion to say that transportation connection is actually a keystone to solving the Sustainable Development Goals. And as I think many of you have probably come across, the UN Sustainable Development Goals are compact that all 191 odd countries in the world have signed or have agreed to at some level, some as signatories and some not, saying that these are the goals and how we are actually going to move forward. And it's not only at the highest level saying, well, we all agree that we want good health and well-being, but actually there are indicators and metrics and ways that we are measuring them, these things globally, that are helping to move the world forward into more an equitable future. I believe that transportation and just the very root cause of access is a solving of poverty lever is one of the most important ways that we can assure that we are achieving the Sustainable Development Goals. I think you can make an argument, it hits almost all 17, but I like to say it's at least a good 11. And so as we envision this world where poverty due to rural isolation no longer exists, Bridges to Prosperity is the largest organization to focus strictly on this mission. We've worked in over 20 countries. We've now connected, I need to update the slide, over 1.3 million people walking across our bridges on any given day. And the impact to those individuals is pretty profound. As hopefully some of you go into the more analytical side of things, you'll appreciate that this is not just a feel-good story of taking some pictures and saying it worked out well. We've invested very heavily in research, and in almost a very similar way that you'll see in the medical fields, where you have a randomized control trial where you say, hey, I want to try this medicine out, and I'm going to test for placebo, making sure that if Avery gets a drug, I don't know if I do or don't have the drug, so I don't have the Hawthorne effect of thinking that I'm actually cured when it's just in my brain. And so medical research for a very long time has done this comparative of control to actual, and then being able to kind of look at a sample size and say, hey, yeah, actually this drug is effective. And we did the same thing with bridges. And we were actually doing this several times in the same environment. But we've partnered with University of Notre Dame, Yale, professors from the University of Colorado at Boulder in Arizona, and a number of other researchers who've kind of come in and helped. And they've been able to help us understand deeply the impact of footbridges. by doing exactly that, comparing communities that receive a bridge and households within those communities compared to communities without. And what we found is really mind-blowing. Not only are women disproportionately benefiting from access, they no longer have to sit at the side of the river and say, well, if I go to work today, I might not be able to come home. And what are the ripple effects of that on me personally and my family? So they're able to predictably go. It's a 59% increase in women entering the labor force. Farmers have the same thing. Well, do I sell my grain today because I know I can make it to a market? Or do I wait till Wednesday when I know that the market actually sells at a higher price? And also as farmers, being able to easily get their seeds and all their fertilizers, that increases their profitability and their yields and their profitability. And lastly, thinking about it from an economics perspective, the increase in everyone being able to get to jobs increases their labor market income by 30%. And as I mentioned earlier, I'm from Iowa, and I like to think about it, and I come from multiple generations of farmers. And I like to think about if I had shown up in rural Iowa and said, hey, I have this, great idea how all of you farmers could increase your earnings, either your profitability by 75% or your job earnings by 30%. I'm pretty sure I'd be the next president of the United States. And so I'm just saying that because Iowa's got outsized, sway in the political arena means that the rural people also oftentimes, if they can start to have more revenue and more money, we might start to have a more equitable world the world over. So in Rwanda has been our big push as Bridges to Prosperity. So like you saw, we've been in 20 countries. We work with many, many rural communities, but we have partnered with the government of Rwanda at the very highest level and worked with them to say, how do you want to solve your rural isolation problem? And what we came out with was essentially about 1 million people that they would like to connect over a 5-year period. It's quite expensive for a philanthropic, charity investment of $28 million. But if you compare that to the cost of much bigger infrastructure that's serving the urban core, so just widening a road or putting one vehicle bridge in a capital city, for example, $28 million is actually nothing. We have billions of dollars going into transportation infrastructure that serves urban core. And so $28 million to solve the problem for an entire country was a pretty, I'd say, easy ask. And the Rwandan government has been a fabulous partner as we have marched forward in that. As we work through our nationwide connectivity, what's really been interesting is that we have a lot of mapping core competencies as an organization. And we've been partnering with all of the districts and cells and sector leaders throughout the country. And what's really interesting to me is in Rwanda, the western regions, the north and western regions are quite hilly and mountainous. And as you go more to the east, you'll have a more, what you might expect is like where you might go on safari, quite flat, more arid. And the direct correlation between prosperity and isolation and hilliness, they're all connected. So the western region in some of these areas where we have the most bridges that we're building are actually considered some of the poorest, which makes quite a bit of rational sense, right? Can't get to where you need to go. You happen to be the poorest folks, also where we end up having an outsized impact. And so with that, I just kind of wanted to give you a small taste of why your activities today and learning and exploring bridge design and construction is important. I'd like to be able to pull us back out and say, hey, you don't have to be a bridge engineer to create a big impact. I know we've got some friends here from NASA and some other great impact organizations. But going into STEM fields more generally, I have preference to engineering, but any number of life science and STEM opportunities will allow us as a society and a world to move a bit further along. And on a human level, I'd love to encourage each of you to think about what are those things that you're passionate about, what are those areas where you think you might be able to find purpose, and encourage you always to remain people-centered. So with that, I believe I have some time for Q&A if I didn't really go too over.
That was, I have to say it, that was outstanding. Captivating presentation. I'm just going to highlight a couple of things and just say on behalf of Engineering Tomorrow, thank you so much. Passion, I loved it. Passion, purpose, people. I mean, if we can all live by that mantra, take our passions, take our purpose and capabilities, hopefully in the science field, and dedicate our lives to improving the lives of others. That's a game changer. Thank you so much, Avery. Such a dope presentation. I'm inspired. I hope you all are inspired. That was amazing. Sheesh. I don't even know how to follow. How do I follow? I'm supposed to follow that up somehow. I don't know. I'm not sure. But thank you so much on behalf of Engineering Tomorrow, on behalf of our founder, Bill Woodburn, who I know is here. Outstanding. Any questions, anyone you want to ask? And I'll stop sharing my screen so you all can engage Avery directly if you have some questions. That was really good. Anyone? Any questions? I'm trying to monitor the chat as well to see if we have anything. I know it's tough. It's tough to ask questions. It was just so good.
Tika, do you have a question? I see a hand raised.
Oh, go ahead. Go ahead. I see a hand. I'm going to ask you to unmute just so you can see the unmute. But if you can't unmute, please place it in the chat as well. And if you can jump off, if you can show yourself, that would be really nice. Get that personal touch going. We can't get her for some reason. Technology. This is why we need you all, youth. Improve Zoom. In the chat, anyone? Oh, I see a question. Is there a bridge design that you felt was more successful in rural locations?
That's a good question. So it really depends. I think there's kind of talked about what you guys are doing with the truss structures, and that's really good when the water level remains low. And you never expect for the water to come up and touch that truss and the bottom of the truss. It's called freeboard, the distance between the bottom of a bridge and the top of the water at the maximum. So that's great for places where you have a lot of control in the water. But as you go into more rural environments, you don't really know how high. Oftentimes the water is less controlled. You have less controlled waterways, less weirs, less dams, less all of the things that engineers do to help us make it so we don't flood our communities, has a downward impact of making the water heights much more volatile. And so if you're in a flat valley, the bridge, like you might have saw on the video, on the film in Haiti, that's going to be a better structure because you can use the towers and put those up, and you have the cables pulling up and over the tower. But the cool thing, it's called camber, but you lift the bottom of the bridge up and over. So if you look at the geometry of a suspension bridge, and this is included the Golden Gate Bridge, is it's not flat. You're actually coming up and over an arch. And little known fact, speaking of the Golden Gate Bridge, the only time it's ever been overloaded and they actually had to stop traffic was when they had it closed off from cars, and it was during the marathon, because people weigh more than cars, especially because of the high density. So that's the kind of bridge that I like in a more flat area, as a suspension bridge with the tall towers. But if you're in an area like Nepal or Ethiopia or anywhere really mountainous where you have a really big gorge and you kind of already have the difference between where the water is and the elevation up here is pretty good, then you can do a suspended bridge, which are those like hammock style, because all you got to do is like go further and further up the mountainside and pop them in there. And then that kind of takes care of your elevation needs, and you don't need to put a tower up to be able to capture it.
Great question, great answer. I see another question in the chat. This is a good one. What are the challenges to making these projects self-sustaining by local populations in view of repair, involving people of the area, and using local materials? That's a good one.
That's a great question. So that's a big part of Bridges to Prosperity's model, is that we hire and employ all local folks, and the bridges are selected, designed, and actually procured by the local government. So it's the same thing I like to joke. It's like if like engineers from Switzerland all of a sudden got this grand idea and they're like, I'm going to fly into Denver, Colorado, and I'm going to tell you where you need a bridge, and I'm going to leave. Well, there's all sorts of things wrong with that, which we don't need to get into right now. But it also is lacking context, and it's lacking the creating the capacity for Denver to be able to make sure that that infrastructure continues to be safe and durable. So we say, hey, we're here as a technical assistance player. We work with governments. We will train local builders. We will make sure the local engineers have all of the technical support that they need. But in that Rwandan program, we have maybe 2 people in total that are not from East Africa that are meaningfully involved from a staff level, three, sorry. And that doesn't mean that you don't have a lot of people around the world making this happen. You know, it's a very much a global effort, but we believe that Rwandans are more than capable of building infrastructure for Rwanda. We believe that Bolivians are more than capable of designing and building bridges for Bolivia. And we are here to do more of the, mobilizing money and making sure that the technical skills and procurement issues are all sorted. It's a great question.
Cool. So we'll just do one more because it's related. How do you get the materials needed to build the bridges to those remote locations?
Yeah, this is like part of the fun thing about engineering is you always have to think about how you get the materials there at the level of quality that you want. So whether, Milton, your level of precision and tolerance and specificity on what you work on is orders of magnitude different than bridges in Haiti. But I've still got to be thinking about how do I get cables that are, an inch and a half big off of gantry cranes in ports from around the world? How do we get them respooled, put them on containers and take them to these new countries, get them offloaded? And then, like you guys mentioned earlier, I'm not driving to these bridge sites. I'm driving to the nearest place I can walk to. So the same thing goes with all the bags of cement. Same thing goes with all the rebar and all of the other materials that we need to build these bridges. We have to think what A, can be procured or bought locally and as locally as possible. B, if it isn't in that local, super local region, how can we buy it still in the same country? And C, if it's not available in the local country, what is the most sustainable way that we can get that material to site or into country, into site? And for us, we try to always use repurposed or recycled materials. So like I mentioned, we're pulling cables off of gantry cranes. You could also do it off ski lifts if you're audacious enough to do that. We're taking towers that used to be used as oil and gas rigging, pull those up, get them load tested, make sure that they can still sustain loads, put them up as towers. And so we're not undermining the local economy. If a material can be purchased and procured there in country, we do that every time. But we're in a global supply chain, and oftentimes things are just not always available everywhere we work.
Think that was a great answer. And last, I'll just make a comment here. This student, Aventika, asked a question: how could they get involved with you in civil engineering, working on this awesome project? If someone wants to work with Avery Bank and Bridges to Prosperity, how do they do it?
Yeah, I'll put my email in here so you guys can just shoot me.
Wow.
But the thing here is, like, we are really excited about the next generation of leaders, and we have spun off an organization called Engineers in Action, the Bridge Group. And the only thing that they do is focus on getting young people in their beginning of their career excited about bridges. And that means going and designing and building bridges around the world. And we're hoping that when folks work with Engineers in Action, that someday they might be a candidate to help us also at Bridges to Prosperity. So I'll make connections there and do what I can to make that all happen.
Very cool. Very cool. So if we could give a big round of applause to Avery Bang for just an outstanding presentation. Thank you for your time. Thank you for motivating us. It was truly inspirational.
Well, thanks for having me, everyone. I know you guys have a lot going on today, so good luck this afternoon as well. It's a pleasure to have a chance to join you.
Thank you.
Thank you.
So now we're going to transition to the wrap up. Let me make sure as I'm sharing. Oh, so welcome back. Welcome back. This is our wrap up. I've been jumping in your sessions. I've been seeing that you all are just building some outstanding bridges. Some unbelievable mass is being supported. Oh my God, I see Stepaniak. I think some folks are ready to present. So I'm going to try to get through this quickly. You're taking care of business. I'm just going to have just one last Slido poll question for you before we show these bridges very quickly, okay? So again, if you could jump on to slido.com again and type in the number 165370. This is my last Slido question for you. And it's an easy one, I hope. What did you like most about this lab? There's so many things I could say. I'm gonna wait for you all. What did you like most about this lab? And let me shout out, I see Stepaniak out there, Mount St. Michael, I see you all, St. George Academy. I know Eleanor Roosevelt from the DMV was here earlier, cool. Someone said watching the videos, the fact that they had a lot of materials to get their job done. Someone said, "Me, that was so nice of you." What? I appreciate that. Had an opportunity to be creative. Yes, I love to be able to innovate. There's no limitations in what you can build, the memories, the bonding. Okay, very cool. Building stuff, very nice. I like that. Talking to some new people, seeing different perspectives. That is great. How you doing, Amari, at the Muhammad School, Shepherds of Hills? I'm just walking through, saying what's up. Mr. Powers, how you doing? Someone said building the bridges. They love the dials, watching it break. Don't you like that? There's a lot to learn by seeing something fail. There's a lot to learn. You actually, someone said I love food. You actually answered my question. This is the main thing that you got to learn about engineering and innovation. Failing fast. Give me a thumbs up if you all can see my screen. I just want to make sure we good. Excellent. Failing fast. The fastest way to succeed is to double your failure rate. If you're not prepared to be wrong, you'll never come up with anything original. Fail and fail fast. I'll give you a very brief example. So I talked about NASA and how we launched these large rockets into space. Inside of these rockets, which this one is carrying 4 spacecraft, there's a little computer inside, just like the computer that you're on. And inside their computer is a little processor, just like the processor you have in your computer and your phone, right? We had one of these processors that we always make sure that before we go into space, we test them. When these launch, just the vibration and the acoustics energy, the sound energy, is so much that it can break parts. So we make sure that we intentionally make them fail or test them to see if they'll fail before they launch, so we don't see if, so when they launch, everything is successful. So all of that is to say, again, don't be afraid to fail and fail fast. That's very, very important. And with that, I also highlighted that, I'm just highlighting to you all, those same equations that you all talked about today, involving elasticity and inertia and length, are the same equations I used to help them solve that problem, to fix that little processor that was breaking and during vibration testing. So, and finally, I'll just say, as we went through all the sessions, one thing I really liked is not only were your bridges strong, but there was some artistic value there for sure. You were innovative. I love that. I love the fact, again, that in engineering, you still can be creative. You still can bring your own individual perspective and creativity to something that meets the engineering requirements or goals. So now we are finally here, and I would love to see some bridges. And when you throw your bridge, just talk about what went well, you know, and what did you learn from some things maybe that didn't go so well that you had to improve. And then we can also talk about next steps. Okay, so I'm going to stop sharing, and I'm going to see if there is a school that wants to highlight their bridge. Anyone ready to do this? I'm ready. Anyone ready to do it? Stepaniak, are you all ready? Are you all going first?
We're about to, right here at the High School for Enterprise, Business and Technology, we're going to be coming up, right? So Uriel, Miss Pope, and Karina, come up with your bridge, and they believe that they have the strongest bridge there is.
Oh, nice. You're highlighted now. Okay, let's do it. Give me the name. Give me the name of the school again. This is great. What's the name?
The High School for Enterprise, Business and Technology. Enterprise,
Business and Technology. I love it.
All right.
Let's do it.
All right. Come.
Uh-oh. This is getting competitive because Wall Trip Rams are saying they have a bridge that's unable to break. Ooh,
So-
sheesh.
So tell them about your bridge, Karina. Tell them how. Yes.
I don't know. Yeah, it's really like strong like bridge. It can hold like the whole bag.
So basically, we put 4 layers together. Popsicle sticks, Chinese. What are they like? Chopsticks. Another layer of popsicles and chopsticks again. And then we put this on the top to kind of like more balance. And we added the duct tape because we thought that it was strong. So like added more like grip and and it was like it was able to like stay like stronger together. You know,
Okay.
like it could hold a backpack that weighs like 30 pounds, 30 ounces.
How-
30 pounds. Wow.
Right, so put it down and show them. Where's the backpack? Bring it. Just take up any backpack that is there.
Hey, I'm admiring the shapes, the trusses, the multiple levels of structure that you developed. Nice, strong base, and added a little color at the bottom as well. I love it. There you go. Articulate the camera so we can see it. Nice. Test time.
Excuse.
Very cool. Very cool. It looks like a lot of schools are ready to do this.
That's a heavy bag.
Oh,
hold on.
nice.
Hold on. We are not seeing the screen here. 1 second. Go ahead.
Wow. Hey, let's clap it up for this school. Very, very nice. 30 pounds. Very nice. Outstanding job. Great, great. And this is the School for Business, Technology, and Enterprise. Did I get that right?
Yeah, High School for Enterprise, Business, and Technology.
Shout out to you all. Great job today. Excellent. Hey, we hope to see you in some more Engineering Tomorrow sessions. I want to see you in the Aerospace and Aeronautics session. That's what I would love. All right. Can we shift to our next school? Highlight our next school. Great. There we are. Bam. Oh man, this is a solid. This school has a special place in my heart for sure. My buddy Christine Boudel, that's there. What are we doing?
This is School of the Holy Child, and we have. So this is my award-winning bridge.
Okay.
I unfortunately couldn't break it because we ran out of weights, and I broke the zip ties. So.
Can you talk? Excellent. Man, I love the energy. Talk us through some of the challenges you had to overcome. Like, what did you have to overcome to design this great bridge? What were some challenges? Can you all hear us? Uh-oh, did we lose them? No? Audio? Oh, okay, all right, well, great, thanks. Thank you all. Next group, excellent job. And thank you, Christine. Next team, who are we gonna highlight next? Excellent job.
More Catholic.
More Catholic. All right, come on up. Let's highlight them. Can I shout out? I'm good. I'm gonna shout out Constance and Monica. Well, what would I do without you all? Oh wow, look at this bridge. Talk about this nice bridge, man.
Well, Valentin made this bridge.
Yeah, I built this bridge.
What were some challenges you faced, Valentin?
Hi, can you hear us?
Yes, we can.
So Valentin, did you have any challenges they want to know with the bridge? He just finished. It took him the whole day to design it.
It's a beautiful design.
Right, and he put a lot of things on top of it to make sure that it worked. See, we had an iPad on there.
No, don't do that.
Very professional.
Yeah.
Oh, okay. All right. Oh, look at that. It's supporting some weight.
We'll just show a few more because I know you want to see other people's bridges, so.
Cool. Very cool.
And
Nice
they put them
hard work.
Yeah, they put them between chairs and they were able to hold about 5 and 6 phones.
Sweet.
So
Thank you all so much. More Catholic High School. Please send us some pictures. We love it.
I will, thank you.
All right, who is next? Who is next? Who is next? Hey, you all are doing an outstanding job.
We have one more from the High School for Enterprise Business Technology. The same 30-pound bag. We have another bridge right here that is holding it up.
Uh-oh, we got a competition for who's just taking over the screen. This is great. All right. Next. Oh, there we go. Talk to us. Well, I think we got to get it. I don't know which school we're doing now. We got to go one at a time. I don't know who's up. Who is up now? Who's next?
America bridges up. Utah.
I'm seeing Gabriel Gonzalez. Let me know what school you're from. What school are you from?
St. John's. Yeah, show me.
This is our,
Real close.
it'll hold 180 pounds so far.
What? Okay, St. John's Jesuit.
Jesuit.
Jesuit, thank you. Wow, I love the artistry there. That's
Show
really
that one,
nice.
do that one, do that one.
Okay.
But like, we just held one of our friends from it. We don't actually have 180 pounds worth of weights, but we did a pull up on it. So
Hey, put that back on.
A pull up. That's serious.
We don't have enough weight for it, basically.
yeah, we need to go to like the weight room and get some like hundreds.
That's amazing. Very nice.
Another.
Zero
Uh-oh,
flex.
what? That's two book bags.
So, like,
Absolutely no tape. No tape. It's paint.
approximately
Very
2 inches
cool.
of tape.
Yeah, the tape at the start.
There's three book bags. 3 bags.
What
That's
what
three bags.
was the most important? What was the key design feature to making this bridge so solid?
The one dowel. We used one stick.
It's the base of the bridge.
The base. You all heard that?
like-
Solid base. Very nice.
There's a lot of R&D in this, and we can talk about it.
Yeah, it's unreleased technology.
Excellent job, St. John's. Thank you all so much for your courage in presenting. That is a solid bridge. Very solid.
I had All Hallows in the chat asked first to show their bridge, but I don't know which All Hallows to highlight. Which All Hallows are we highlighting? While we wait for All Hallows to tell us, I think the next one was Shepherd of the Hills. Are you guys ready, Shepherd of the Hills?
Shepherd of the Hills.
All right, your guys are up.
We can see it. We can't hear you yet. Oh, there we go.
Hold like 10,000 grams because we're not advanced.
Oh, very nice. Talk to me about that design. I see the artistry. Yeah, nice.
Okay, so we did 4 layers. We
Okay.
did 4 layers down here, and then we did some like supporting up here too. And then we gave it a nice banner.
Oh, nice, nice. And how much weight could it support again?
Like 10,000.
10,000 grams. I love how you portrayed the mass. That was smart. Very nice.
Yeah, it's not like super like we're not that good at engineering.
No, you all are great. You're on your way. You're on your way. And this is Shepherd of the Hills.
Yeah.
Great job, y'all. Let's clap it up for Shepherd of the Hills. Nice. All right. Okay, I see the dance. Nice moves. Next school.
Is
That
this
was-
All Hallows that we want to highlight? I'm trying to pin it for everybody. They don't have their camera on yet, but they have their hand raised. You guys ready? Wrong All Hallows? Oh, there we go. You gotta unmute, guys.
Can you hear us? Can you hear us?
Now we can hear you.
All right. So we actually made a bridge. I think if the max weight was what, like 20.5 kilograms? Yeah, 20.5 kilograms. And what we did was actually we tried to use less materials, but you know the big sticks that were here, we actually broke them apart and put little ones here and put tape around them
Nice.
support them. And we actually used 2 of the glue sticks. So we ran out of glue, so we actually put duct tape on it and we like wrapped it around.
Are you going to test it or have you tested it already?
Well, we tested it already. If you can't see, it's kind of dilapidated. But
Oh, I got it.
no, for how many weights we had, we maxed out.
Cool. I love your description of how you tried to reduce resources. That means that if you weigh that structure and you compare it to how much it supported, you can get the structural efficiency. I wouldn't mind hearing that, right? Like take the mass that you supported, which may have been 30 pounds or something, versus the mass of that structure. I bet you're going to have a really nice structural efficiency.
All right.
Great job, you all. Hey, I can't wait to see you in some more Engineering Tomorrow Lab soon.
All right.
Let's clap it up for All Hallows.
All right, I think
Okay.
is Stepanak next? All right.
Okay, so we have a bridge that's 7.5 feet long.
Wow. Okay. Okay. Wow. Look at that. Oh, what is this? What is going on? This is awesome. Look at that. No deflection. What is this, like a lunar rover? Oh, good catch. Man, I could see that teacher's heart drop in his body. Outstanding job. Great job.
All right, we got Waltrip is next. Waltrip, you guys ready?
Yeah.
Great
So
job, Stepaniak.
we're wrapping up. We're here.
Okay.
So we're still testing bridges. We've had 3 so far that we haven't been able to break. We're
Wow.
moving on to the weight room to get weights. So we've done 40 pounds of nails and 15 cans of spray disinfectant and haven't been able to break that bridge. And then we've had some other ones that have had some learning opportunities.
Okay. Okay.
But we're having a good time. Thanks, guys.
Thank you all for spending some time with us. And I love, this is like a machine shop in here. You got a whole bridge production
Nice,
going.
Mooney.
Oh, man.
Our machine shop, our wood shop, our
Wow.
CNC machines, and in the next room we've got our 3D printers, lasers, and vinyl cutters.
Oh, man, I'm so jealous. I got to visit
Come
this
visit.
awesome school. Oh,
Come
I
visit.
need to. Wow. 3D printers, CNC machines, wood
We
shop.
have a
Oh.
450. It's a $180,000 3D printer. It's an 18
What?
cubic inch printing surface. It's better than the printer at NASA.
I bet it is. Did you? I love the competitive spirit today. Better than the
Well,
printer at
because
NASA.
NASA's down the street and they come over and borrow our 3D printer.
Which where are you located?
Houston.
Got it.
You know, Houston,
Yep,
we have a problem.
Yep. Houston, we have a problem. Johnson
Thanks.
Space
We really
Flight
had a good
Center.
time.
Great. Thank you all. I want to see you in some more labs soon. Hey, let's clap it up for Waltrip Rams.
Oh, Rams!
Okay. All right. Is this our last school here? Is it North High School of Community Leadership? No, that's Mr. N in High School of Community Leadership. I got you.
We got some textbooks.
Okay. Talk to me about this design, because this is innovative. It's different. What was the strategy?
He was just thinking isosceles triangles, I believe.
Oh, hey, triangle, extremely strong structure. That's great.
That's 2 textbooks. I guess another book bag with another hook.
Oh, the anteing up the weight here. That is solid. Wow. Very nice.
We had a great day. Thank you guys for everything. You know, the kids it's very memorable for them. And
Cool.
you know, our principal ordered us and everything. So thank you guys.
Thank you, High School of Community Leadership. Clap it up for them again. Outstanding bridge. Okay. Do we have another? Or are we wrapping?
Can you also share?
Okay. All right.
All right. Come on.
HSCL. HSCL.
So for this one, basically we made it a strong top, and we're just gonna see how much weight it could take from the top.
Oh, so you're tackling this a little differently. How much weight can the bridge support on top of it? Got it. Oh, look at the books. Those are some serious books.
I think each of them is like 5 pounds.
Okay. Okay. Cool. There's another. Uh-oh.
That's how else one it could take.
That's very nice. Very nice.
It's a butterfly.
Great job. Talk to me some about how you came up with this design.
So basically, we put a whole bunch of what's it called? The spaghetti things.
Yeah.
On top, and then we duct taped it to make it like very strong. And then we also put the popsicle sticks on top as well, and then duct tape it again. And then
Cool.
on the side, we did the same exact thing.
Cool. I can see some future engineers
No.
in the making. Very, very cool.
It was all of them.
All,
Yeah, yeah.
oh, great job. Give me the name again. HSCL. How do I? What's your full school's name?
High School for Community Leadership.
High School for Community Leadership. Clap it up for them. Great job.
We're in Jamaica. We're in Jamaica, Queens.
Jamaica, Queens, represent. Nice. All right. Well, thank you all again. You all are outstanding. On behalf of Engineering Tomorrow, we want to say this was such an outstanding session today. Let me share my screen one more time if I have the ability to. And we do want to say this, you know, if you all are interested in science, technology, engineering, and math, there are careers out there. You are on your way. Civil engineer, materials engineer, architects for sure. It's one, you make good money, but two, you have a great purpose. But finally, we want to remind you that you could do this right now with the skills that Engineering Tomorrow wants to bring to you, and the skills that your awesome teachers and your schools are bringing to your programs. You should be applying to internships. If you want to know more about that, please contact Engineering Tomorrow. We want to talk to you about that as well. Hey, I think that is our time. I am going to hand it over to Monica or Constance to close us out. Is that you, Monica? You rolling with me?
I think Constance is going to take it today.
Okay.
No,
Okay.
you got it, Monica.
Okay.
Oh, okay.
Okay.
Well, I put already in the chat the exit ticket. We want to hear what you thought of today. So please make sure everybody completes that exit ticket. You will get an email with the exit ticket. So if you didn't get to pull it out from the chat, don't worry, your email is coming soon. We will also share a recording of the session. So if anybody missed it part of the day, you will have that. Thank you guys so much for participating, and hope you guys sign up for more Engineering Tomorrow. Thank you to Milton and to all our presenters today. I don't know if you saw in the chat, Milton, you are the King Engineering Tomorrow instructor.
What?
Yes.
No, I got to shout out to all the Engineering Tomorrow instructors that are just awesome. And what would I be without Constance and Monica? You all are Batman and Robin. I'm just trying to ride
again,
your coattails.
Thank you to everybody. What a wonderful day. Don't forget to complete those exit tickets, and we will see you for your next Engineering Tomorrow event or just a regular lab in your classroom.
That's right. See you in the next lab. See you soon.
Thank you. Thank you.
Yeah, I can find out.